stage, Festival of the Spoken Nerd. So, introducing to your left, she's got a physics degree. She's done work at CERN's Comedy Night. Put your hands together for Helen Arney.
Thank you. And introducing in the center, you might have seen him doing experiments on Blue Peter. Yeah, about 10 years ago. And he won't stop going on about it. It's Steve Mould.
And finally, introducing the man who puts the fun into fundamental theorem of calculus. It's our stand-up mathematician, Matt Parker.
Yeah. All right. All right. Now, together we form Festival of the Spoken Nerd, and this is our show Just for Graphs, where we celebrate everything that's great about charts, plots, and diagrams.
Woo!
Yeah.
Yes, because graphs are magnificent. It's the way you take science and maths and put it in a form that can go through your eyes, into your brain, and touch your heart. So I'm serious. Look at this. This is Darwin's Tree of Life, a simple graph-like sketch that shows us how we're all related. Or this slightly updated version that in a single glance can teach us the science of life itself. Oh, graphs!
Yeah, all right. That's Helen's idea about graphs, all right? Let me tell you about graphs. Graphs are simply for plotting the results of your experiments.
Well, that's like 1 to 1.5 opinions at best, right? Whereas we all know plots are just about taking things and putting them on axes with correct labels, units, and a title. Yeah, now that's a plot.
We have one rule here at Festival of the Spoken Nerd. That is to keep your mobile phones switched on during the performance. Of course, that is to tweet #JustForGraphs. And also, in the current climate, you may wish to fact-check to make sure our jokes are in line with current experimental evidence.
That's true. Though, keeping your phones on can be an emotional roller coaster, which I've plotted on a graph. So you can see your phone charge will go down more steeply in the middle.
That's during the interval.
What of Matt's boring bits?
I have a different emotional journey because I have an iPhone.
Whereas I have none of these problems. Yeah, I mean, I can't take photos, but I haven't charged that thing since 2004. So good.
All right, let's find out about you using my favorite graph of the show. Give us a cheer if you would describe yourself as a nerd. Give me a cheer if you describe yourself as not a nerd. Yes. That is the data we were looking for, so let's adjust the circles and push them together to form the first Venn diagram of the show.
No, you can't. No.
Woo!
You should have seen this guy's face when you put that up, right? You know, because you're right, because there's no one is simultaneously. Like, it's mutually exclusive, right?
No. I'm thinking of people who are psi-curious, yeah? That's you. And Schrodinger's nerd, who I am reliably informed is here tonight. And not here tonight. We haven't seen them yet, we can't tell.
The point is, you're all very welcome.
Oh, yeah, no, it's a lovely graph, but my favourite plot is when earlier this afternoon I put some random numbers on some axes. For no obvious reason, I then added a trend line. There you go. So, very slight negative correlation to tonight's random data. But it doesn't mean anything, right? Because it's just random data. It's meaningless. It's not.
Whereas my favourite chart is the chart of how well I understand pie charts. I'm more of a diagrams guy.
All right, so to kick off this Graph a Minute spectacular, ladies and gentlemen, put your hands together for the first experiments from TV chart throb Steve Mould!
Thanks very much. All right. So, these first experiments are about waves. We're going to start off with waves of a Mexican nature. Yeah, that's right. You know how it works. We'll start off over here, and good, putting your beer down. That's good. You're just like, I can finish this. That's good. Go like that, and it'll sweep across the room. It'll be amazing. Okay, 3, 2, 1, go. Oh, hey, up into the balcony. Amazing. That was really good. Let's try it again, but we'll have a Mexican wave from this side and a Mexican wave from this side. Yeah. They're going to cross over in the middle. It's going to be beautiful. All right. 3, 2, 1, go. Oh, yes. And they kept on going. That was so good. Now, people in the middle, I like what you were doing, but what I really wanted to see was the superposition of two waves, right? Twice as high. Twice as high in the middle. That's what I wanted. It's all right. You've got a chance to redeem yourselves, all right? We're going to have a Mexican wave from this side, and from this side, we're going to have an anti-Mexican wave, all right? The way that works is, you start off neutral, right? Then you dip down and come back up.
It's actually a negative amount of fun.
And when the two waves meet in the middle, work it out. Okay. All right. 3, 2, 1, go. Oh. Yeah. It didn't carry on this. That was odd. And then some people just sort of going, okay, this is what needed to happen in the middle. Nothing. Yeah, you did that. Was that apathy, or you worked it out, or what happened? You worked it out, fantastic. Okay, but imagine this. Imagine we had lots of waves coming from both sides, like this. So when they meet, you end up with something called a standing wave. When they combine, you get this. And when you have a standing wave, you get these points called nodes, these points that aren't moving. That's you, sir. Massive node. Well done. So I'm going to see if I can create a standing wave, not with you, but with sound instead. So what I have here is a hollow aluminium tube. It's completely empty. At one side, I've got a speaker, and at the other side, there's a piece of wood. So if I play sound waves into the tube, they'll get reflected like this, and we'll have sound waves passing from both sides, and we should be able to see a standing wave. Is that something you would like to experience? Yeah. Okay, here we go, ladies and gentlemen. A standing wave. No, don't patronize me. No, there is a problem here, which is that you can't see what's happening because air is invisible. Also, it's inside a tube. But this is why graphs are important, because if you can't see what's happening, then you draw a graph of what's happening, and then you can see it. So I'm going to draw a graph of how the pressure is varying inside this tube. But this graph won't be on paper. It won't be on PowerPoint. It will be on fire. So I've got my butane gas here, and the first thing I need to do is fill the tube with butane. Because it's a safety thing. Basically, if 15% butane is explosive. So I need to get past that. So.
Fun fact, Steve can smell percentages.
It's like the worst superhero power ever.
Except Matt is strangely jealous. Yeah. Okay, so let's see what happens. So it's a sort of long, thin barbecue. And so it's actually a resonance, so I have to get the frequency just right. Let me see what I can do here. Yeah. Yeah, there you go. Oh, hold on. There it is. Ah, beautiful. Look at that. And so look, that's a node as well. That's you, sir. Again, let's see if we get a higher frequency, we'll get more bumps. Let's just try and get to. Oh, there it is. Yeah, beautiful. You are nailing that ooh thing, by the way.
We have to show you a few of these because we paid the clangers for the rights to use their voice.
Okay, I'll do one more. See how high we can get. Ooh, there you go. This is my favorite, actually, because it looks like little hands. This one's very rude, look. Anyway, so let me explain what's happening. So, a tall flame means the pressure is varying a lot at that point, and a short flame means the pressure is varying not very much at that point. So brilliantly, what we have is a bar chart, but it's a bar chart made of fire. Ladies and gentlemen, let's hear it for the Rubens Tube.
I bring to you a lullaby from the bravest space traveler that ever lived. You left this Earth 10 years ago in search of distant comets. Then last November's headline news was that you landed on it. We knew that there was something wrong when we saw your battery. But thank Newton, you weren't running any eye technology. So now I sing a lullaby, and I dedicate to thee the bravest little fridge-sized probe in all the galaxy. Sleep well, little Philae, you fulfilled your destiny. 4 billion miles on the clock to do a science on a rock. You jumped down from Rosetta, it was so good you jumped again and again. Whee! Low gravity! But when you came to land, it wasn't quite what ESA planned. So you deployed the best technology from 2004. But that didn't stop you getting all the data you went for. The newsrooms of the BBC resounded with the echo of presenters wrestling with these words. Chimney, Gary Lineker-Menko. We watched with rising horror as your batteries ran cold. Your solar panels, it turns out, don't work so well down a hole. Now the only true space cowboys are Jamiroquai and you. Maybe Bruce Willis too. Like a miracle, you woke up when the sun came into view. So you used your last battery to send a tweet. Which of us wouldn't? So sleep well, my little Philae, you fulfilled your destiny. You rocked that rock, and that's how you roll on Comet 67. P. Thank you very much.
All right, give me a cheer if you're ready to plot some parabolic functions. That was disturbingly genuine. Yeah, if you love parabolas, put 2 hands up. Who's with me? Yeah. That was most, but not all of you. Ah, negative x squared. Right. And this is the problem, because while a few of you would love me to now do my 3-hour lecture about the various derivative functions of polynomials, 50 Shades of Gradient. I've been reliably informed that such people are technically outliers, and so I've had to put a thing or two in place so everyone can enjoy parabolas as much as I do. For a start, I've brought a physical object. I have a tennis ball, because if you throw something up in the air and it comes back down again, it will move in a perfect parabolic arc. Oh, assuming there is no air resistance, and assuming gravity is constant, and assuming the Earth is the infinite frictionless plane we all wish it was, in that case, perfect parabola. Now, if I've learned anything from working with these guys over the years, is how to take something otherwise quite interesting and make it a bit more lowest common multiple. And you've got two real options there. You can either write and sing a song about it. Not doing that. Second option, set something on fire. Yeah, and that I can do, because frankly, it involves a lot less talent. So what I'm gonna do is I'm gonna soak the tennis ball in paraffin on this side of the stage, set it on fire, then I can launch it in a flaming parabolic arc. Okay, I'm gonna be honest, people at the back, I'm pretty excited right now. That really tapers off as a function of how close you look downright petrified, sir, right? And so, obviously, I had to clear it with the health and safety here at the theatre. I said, look, I got this great different experiment. I'll convince you I should do it. Meet me out the back in the dark car park. And they did, right? And there I had set a tennis ball on fire. Holding it with tongs. Not an idiot, right? And I said, what I'm going to do is launch it, flaming parabolic arc, land safely in a bucket of water. Allow me to demonstrate. Here we go. Ready? Flaming parabola. Missed the bucket. Look, the bucket is barely on fire, all right? And it's gonna take a few goes. Here we go. Take two. Ready? Here we go. In the bucket. You know, if I pause it there, that suddenly looks a lot more dangerous than I remember. Okay, here we go. Right, so here we go. Ready? In the bucket. Here we go. Parabola. Missed the bucket again. It's fine. I chased it across the car park. Got it out from under a car. Safely put it in the bucket of water, all right? And you can see what I'm going for, because if you put all of that together, there's your flaming parabolic arc. That's an actual plot on fire. It's not a bar chart. What is this? A bar chart? Primary school? Come on. That's a plot on fire, but it turns out, very sadly, we're not allowed to do that in here. I know. I said, look, would it be safer if instead of the bucket, Steve catches it? Still a very firm no. And it's okay, because I've got another plan which is even better. So if I can't set a parabola on fire, forget the tennis ball, I'm going to use a different physical object to set something else on fire. This is a paraboloid, right? So this is what you get if you take a parabola and you rotate it around into 3D. And it's the same shape as a satellite dish. And what I'm going to do is recreate an experiment that they used to do at the Royal Institution with two paraboloids. Oh, which I actually came across because I work as the warm-up guy for the Royal Institution Christmas lecture filming, so... Yeah. I don't want to use the phrase living the dream out of turn, but there you go, right? And what they used to do at the Royal Institution was set up two of these so they're facing each other. And because the cross-section of these is still a parabola, and because of the gradient of a parabola, if you put something at the focal point of one, you can beam it across the room and focus it back in again. And they used to put a very, very hot cannonball at this focal point, beam the heat radiation across the room, and focus it back in on some gunpowder. We are not allowed to use gunpowder. I asked about that, and apparently we're not allowed to because it's no longer the past. So instead, Steve has very kindly got some flash cotton that he set up there for me, nitrocellulose. Helen over here has very kindly set up a heat lamp. So what I can do is put the heat lamp in this focal point, beam the heat across the room, and when that catches on fire, you all burst into applause. Here we go.
Or flames.
Whatever happens, here we go. So, that's...
Oh. Ow.
Sorry.
Yeah.
Sorry, it takes a little while to get it perfectly focused on Helen.
Yeah.
Okay, so you... Actually, Steve, I can't see it. Can you tell me when am I on it?
I can't see anything now.
Oh, come on.
Actually, that's not true. I can see one thing, and it's everywhere I look.
Yes! Yeah!
shout out for me. What's your favorite type of diagram? It's got to be Venn, hasn't it? It's everyone's favorite diagram. I tell you what, if you like Venn diagrams, I've got an amazing diagram you're going to love. But let's look at Venn diagrams first. Let's look at a traditional, classic Venn diagram, 3 interlocking circles. So imagine we've got spoken nerds, Australians, and famous scientists. This shows every possible combination of those 3 things. We can now go through and look at the different regions to see what should be in there. So, for example, Dr. Brown, who discovered Brownian motion. Doc Brown, who discovered time travel. There's Matt Parker. He's a spoken nerd and an Australian. There's a generic Australian. This is Doppler, who discovered the Doppler effect. He's Austrian, actually. I couldn't find Australian, but... and there's Helen, and there's me on Blue Peter. Now, the region in the middle that's all 3 things combined, that's actually empty. There's nothing that fulfills those 3 criteria simultaneously. And if you have an empty region on a Venn diagram, then you have to shade it to let everyone know there's nothing in there.
Steve, you promised up-to-date data.
Oh, fine, yeah. Now... Shut up. This is actually only one approach to this type of diagram. The other approach is, instead of showing every possible combination of regions, you draw the circles in such a way that you don't have empty regions. You only show regions with things in them. To do that, you just have to move the circles like this. And there you go. No more empty regions. And you're probably thinking, that's a pretty awesome Venn diagram. But you'd be wrong. It's a pretty awesome Euler diagram. Yeah, I know, yeah. I've been calling it the wrong thing all my life. I thought this was a Venn diagram. It's not, it's an Euler diagram. The important difference is, with a Venn diagram, you must show every possible combination of things. With an Euler diagram, you only show combinations that aren't empty. And in my opinion, the Euler diagram is the more versatile diagram. That is not... that is not popular. Let me show you an example so you see what I mean. So imagine we've got Ireland and the UK. So we've got Republic of Ireland, Northern Ireland, and Great Britain. So far, so Venn. But check this out. Pow, pow, pow. Pow was probably the wrong word. But anyway, you see, that's another example. Things people do, things done for you, things Bryan Adams does. You see, that's that sort of thing. Now, very versatile diagram. The other thing with Venn diagrams is they can be quite hard to draw. Like, okay, so how do you draw a valid 4-way Venn diagram? Remember, with a Venn diagram, you have to show every possible combination of things. So, is this a valid 4-way Venn diagram? Let's find out with an example. So imagine we've got corn, nuts, crunchiness, and flakiness. So in the middle, obviously, crunchy nut cornflakes. But let's have a look at the other regions. We've got nut corn, crunchy flakes, crunchy nut corn, crunchy cornflakes, nut cornflakes, and flaky nuts. And crunchy flaky nuts.
In some of those cases, you should seek medical attention.
But there is something you can't have with this diagram. You can't have cornflakes. Yeah. I mean, you can have cornflakes, but just not with this diagram. There is no region on this diagram which is corn and flakiness without either crunchiness or nuts as well. It turns out that it's impossible to draw a valid 4-way Venn diagram using circles. You have to be more creative with the shapes that you use. A valid 4-way Venn diagram looks like this. Yeah. A valid 5-way Venn diagram looks like this.
Well, little nerdgasm swept the room there. Nice.
Actually, let's fill this one in with an example. So imagine we've got girls and boys. So the crossover is girls who are boys. Then we can keep going. So girls who are boys, who like boys to be girls, who do boys like their girls, who do girls like their boys. And that always should be someone you really love. Thanks. If you're thinking that would look amazing on a T-shirt, check out our online store at festivalspokennerd.com. Guys, do you want to see a valid 7-way Venn diagram?
Yes.
Pow.
That's a multiple nerdgasms.
So it is beautiful, but it's also very complicated. Venn diagrams get very complicated very quickly, unlike Euler diagrams, which are only as complicated as they need to be. Another thing that is slightly complicated is the fact that some diagrams are Venn diagrams and Euler diagrams at the same time. So I want to clear that up for you with a diagram. So Venn diagrams look like this. Euler diagrams look like this. This diagram is a Venn diagram and an Euler diagram, so obviously that goes in the middle. But obviously then that has to go in the middle. And then obviously, that has to go in the middle. And then that has to go in the middle. Yeah. Ladies and gentlemen, I present to you your new favorite type of diagram, the infinitely recursive Venn-Euler diagram. Thank you very much.
We now have to very briefly put the theme of the show to one side and address the fact that we have all lived through the year 2015, which was a very mathematically significant year. Not just because in binary it is a palindromic number, as lovely as that was, even more importantly, 2015 is the year they went to in Back to the Future 2. So we are now living in the post-Back to the Future 2 future. And what an eerily accurate prediction of our modern lives it was. They got so much so right. They predicted in the year 2015 most films would be sequels, and that definitely happened. Pointlessly in 3D, may I add. They predicted most video games would be hands-free. So in this scene, they make fun of the fact you have to use your hands to play the game. Oh, and that's Elijah Wood. So they predicted in the year 2015 Elijah Wood would look adorable. And that's true. They predicted the rise of the double tie. I think we can all agree it is a mighty fine look. It's a week of my life you're applauding right there. I had to sew magnets into a shirt. You have any idea how hard it is to iron a shirt with magnets in it? I got it. It's a fire risk at best. They also predicted teleconferencing. He's on Skype there with his boss. And in the scene when he gets fired, his boss sends a "you're fired" message through the many, many fax machines which are all around our homes. Okay, sadly, it didn't get this one completely correct. We now live in a post-fax world. That's a terrible joke. It gets worse, because occasionally I describe that as being the main fax, and this is an alternative fax. That's going to get edited out, so don't even applaud. Right, so no, but to be honest, you can see why they thought from in the 80s that we would still have fax machines. What an amazing device. They can send images like across phone lines. I looked into them and they are very interesting the way they work. If you've got a photo you want to share with lots of people by faxing it to them, something you're very proud of, when you put it into the fax machine, it scans it row by row. And if there's no detail, it sends a 0. If there's detail, it sends a 1. And then it takes all that information, encodes it up somehow, sends it over the phone line as audio. When it gets to the other side, it's decoded, reassembled, and then the fax machine prints out wherever there is a 1. And so it is on theme because it's a plot. Fax machines used to just send the coordinates of the detail in your image as a plot. And what a photorealistic okay, this is why we don't really have fax machines. The resolution wasn't great, but it was good enough, right? It was good enough for example, the first ever image sent from the surface of the moon, right? This is the first image from 1966. Soviet lander sent it back to the Earth. And the data coming back, anyone with the paraboloid could pick it up. And so the guys at George Bank were getting the data coming back from the lander, and they listened to it and went, that sounds like a fax signal. No, surely not. But just in case, they borrowed a fax machine from the Daily Express, they ran the audio through it, and this printed out. They believe they decoded this image and printed it before the Soviets even did. Absolutely phenomenal. Surface of the moon. And that was the front cover of the Daily Express the next day. To this day, a well-respected scientific publication. Right, and even in the 1960s, faxes were old technology. The first patent for a fax machine was from 1843, right? It was this ridiculous kind of pendulum system that had synchronized pendulums across the telegraph line because fax machines predate the telephone. And more importantly, 1843 predates 1885, the year that Back to the Future 3 was set in. So they could have just sent a fax from Back to the Future 3 to Back to the Future 2 and just skipped the whole rest of the mess, right? And so once I was this obsessed with fax machines, I was like, well, I've got to own one now. And so I went on eBay, and people are just getting rid of the things, right? So I bought myself a fax machine. It arrived. I was very, very excited. I took a selfie of me with my fax machine. I then faxed that to myself, and I was there going, oh my God, I've got a fax machine. And then I realized, even though I've got a fax machine, no one else does. I was like, what am I going to do now? And so I thought, well, you know what? I need to get more people into faxing. And I realized that fax machines didn't stay with the times, right? They didn't go mobile when everything else did. And so I spent more of my free time than I probably should have developing, well, I can now present to you the world's first mobile touring fax machine. Gonna be honest, that was slightly more patronizing than I was hoping for. All right, I mean, look at it, it's a mobile fax machine. It can print out faxes live on stage. And so what will happen, in the interval, you can download a fax app, right, and you can send me a fax and it will print out, right? This is actually happening. When you download the apps, be careful, some will charge you for a bundle of apps or paper app. Some apps will give you one free fax per day. And we know that because people come to the show and then continue using their one free fax per day to fax me. Well, there is one guy, was it the show we did in New York on tour? Yeah, York, right? There's one guy now, whenever he gets drunk, he drunk faxes me. Right? It's just happened.
He calls himself Jeremy Faxman, so we let him off.
This is pretty funny. It's pretty funny. It's pretty funny. So this is. I'm so excited by this. If anyone is confused, because some people are still looking at this with a state of confusion, I can clear up what's going on here with a diagram. So there you go. Pow! Right. So good. Okay. You know, I think because of this tour, people across the nation and indeed the world are now getting into faxing. We have started the fax revival depicted in Back to the Future 2. We are the Skynet. Oh, we're not. To be honest, I spent so long deliberating whether or not I could, I didn't stop to think whether I should. But I have. And so my fax number, we'll put it back up in the interval. It's not plugged in yet. Don't start now. It starts, of course, with root 2, and then 404, and then 255R9. So they're the digits. Some of you would prefer to see it this way around, as it's prime factors. So I will put that back. No. I will put that back up on the screen in the interval, and you genuinely can fax me up. Thank you very much.
So we're almost at the interval. You genuinely can fax Matt up in the interval, but for everyone else, there's something you can do, which is send us your graphs. So we've created and printed out some blank bar charts, pie charts, plots, and Venn/Euler diagrams. There's a big pile of them here with some pens. Draw us your favorite, or turn over the sheet of paper and do whatever else you want on the side. Bring them back to the front, and we'll show our favorite ones on the screen after the interval.
Or fax them down.
All right, well, we have one last experiment for you before we do that interval. And this is an experiment that really touches me as a human being. And I know will touch many of you here tonight. And it starts with one of my favorite things, which is a sound wave. And this sound wave can be drawn as a graph. You can put some axes on it, and you get how a sound wave travels through the air pressure versus distance. That's how you get to hear things. But if you take this same data and turn it into a different graph, you can have a bit more fun with it. So if you play a sound wave into a microphone, that turns it into an electrical signal. It's the same data. It's the same graph. but this time the axes are voltage over time. And this is what we're going to have a play with. So over here, Steve has set me up an amplifier. Going into that is my iPad with a very large collection of copyright-free music. And over here, I've got another amplifier. Coming out of that is a tiny speaker. Now, this isn't connected to the PA, so if you hear anything coming out of here, it's just going through the amplifiers. And to connect these two together, I've got a speaker cable that ends in some bare wire, and another speaker cable that ends in some bare wire. So what I have here is bare wires. Now, if I was 14 and from South London, that would just mean I have a lot of wires. But what it means here is I have two bare copper wires, and ladies and gentlemen, I'm going to send this sound wave from one side of the room to the other. Here we go. Right. Your whelm is very much under. And that's fine, because all I've done is repair a speaker cable. That's not what I wanted to show you. What I really wanted to show you is this.
Okay, she's not dancing, she's being electrified. That's...
Genuinely, this is actually going through me. Ladies and gentlemen, I am Become Graph! Thank you very much. I mean, and the reason this works is because I am a human, because humans are about 70% water, and water is not a great conductor of electricity until you add salt. And I am incredibly sweaty right now. So all I am, ladies and gentlemen, for you, is just a sack of electrolytes standing on a stage, asking you to love me. That's all I am. That's all I am. So what I wanted to do is scale it up a bit. So I'm going to play DJ, and you, Matt, are going to take that one. Steve, you take that one. And I need you to make a really strong human connection. You know, I really need you to hug or hold hands or...
A high five.
Okay, well, that's fine as well.
Yeah.
All right,
Nice,
okay.
friendly
Let's
high
do this.
five.
Okay, and do it.
Hang on, it's like the very end of the show. Ready, watch. Huh? Hey. That's through his shirt!
It's been a couple of days.
Through his head?
Can I stop? Thank
It's
you.
a very serious science show in some regard.
All right. Okay, that's good. And I can see you're having fun, but there are some people on the front row who I'm pretty sure want to get involved in whatever is happening here. So front row, I want you to make a really strong human connection between all of you. I want you
What
to...
she's saying is, you have to hold hands. Oh, you are? No, fantastic.
That's
Okay.
why you came to a nerd show, to hold hands with strangers.
All right, just before we do this, I need to check, does anyone on the front row have a heart problem or a pacemaker? Okay, I want to check that. Don't look worried. We have measured the current on this, and it is either so low that our meter can't measure it, or our meter's broken. We don't know. But it's going to be fine. All right, so let's turn this into a front row speaker cable. 3, 2, 1.
Yeah.
Nice.
You're way too trusting. So we know it's convincing. Actually, would you guys mind? You're going to be the official audience jerk. All right? Could you, when you do your content, we'll do it again. Can you hold your hands up so we can see and occasionally let go and ruin the fun for everyone else? Here we go. Ready?
All right, so...
As a little convincer. Here we go. Ready? Oh. Connect.
Oh, well, no.
Connect.
What? Okay, wait, stop. No. Are you holding hands some other way? Okay.
I got some bad news about how dangerously conductive the seats are.
Fine. I mean, that was lovely, but this is our DVD recording here at the Albany Theatre, and it's a sold-out crowd, and I just feel like I want to give everyone like a big electrical hug, like I want to really connect with all of you on a human level.
What she's saying is, you've all got to hold hands.
No. The back row are going to hold hands, right? So the very back row over there, the back full row, you guys give us a wave. One in front, those guys there. So we've got the complete distance. Yep, you guys, right. You're all going to hold hands. It turns out reluctantly. And then we're going to run the signal all the way down the outside, inside, like on the very edge of the stairs on both sides, back around to the front. Okay, so off you go. So can you guys hold hands? And then can someone bridge the gap over there?
Right.
And then you guys over here.
We're going to need a few more units. And by units, I mean people, okay? So I want
So
this
you're
to
gonna
go
touch-
all the way up there, along the back, and down the side.
Right,
You can
so
do
you
this.
touch the person behind you there. Touch him, yep. And then you touch... It's like the world's most pedantic orgy over here. Touch him, but not him.
This guy's very polite. He went like this first, which I thought was quite nice.
Touch them,
No,
good.
no, that's
Good.
not good. You need it like as damp as possible. Like, yeah, like,
No.
yeah.
Okay, I've lost track of... Can everyone who's touching someone... That's not... For the purposes of the experiment, can you hold your hands up so we can see the complete...
Okay,
would
that's
you guys mind
looking
standing
good.
up and come
And
over
then
here?
if we could get
You
chains
guys
to
over
the front
there.
here.
Okay.
Yeah.
That is looking good. All right, let's do this. Everyone in the room, feel the energy in the room, ladies and gentlemen. Feel the energy in the room.
When she says feel the energy, she means feel the voltage times the current times time.
Yeah. Yes.
Or the current square divide... Oh, forget it.
That as well. All right, let's do this. On 3, 2, 1. Yes!
Yeah!
Keep it going!
How?
Ladies and gentlemen, this is the human speaker cable of the Albany Theatre!
Ladies and gentlemen, please put your hands together and welcome to the stage. It's Festival of the Spoken Nerd! All right, Albany! It's still going!
We have been inundated with graphs and with faxes. We're going to go through as many as we can in the next 5 minutes. Matt, do you want to kick us off with some faxes?
Come and teach the brightest and best with us. We're looking for intelligent, dynamic maths teachers. Who said maths teacher spam? Stop trying to recruit us. Okay, who faxed in binary? Oh, you are lucky I'm fluent. Space. Who starts with a... Oh, wait. It's not just the one page. Oh, my goodness. Who said that? According to all known laws of aviation. It's the B-movie script, isn't it? Oh, my goodness.
We had to go out and get extra paper in the interval.
It's the entirety of the B-movie. I thought the cost per page would stop you from doing this, but no. It's split across several faxes. Right, I'm gonna take out all of the B-movie, and then we'll come back to this.
All right, what have we got on the physical graphs? in the
So
room?
in the category of sort of homonym-based, so we've got like an actual bar, for example. So there's a bar chart there. So like an actual plot. So you go like a garden plot. Quite a nice variation on the garden plot. The plot thickens. There you go. They have no idea about crop rotation. And we've lost the plot. Quite a few in the vein of things that look like other things. So, you know, looks like Pac-Man doesn't look like Pac-Man.
Steve?
Yeah. Oh, okay. Yeah, maybe... Maybe this is actually in the vein of joke I found on the internet and drew. A spectral analyzer. Let's pull that back. There we go. That's...
That is spooky.
Faxes.
Oh, actually, I've got one about faxes. This is faxes sent as a function of time.
It was for the drop-off. We got so many of these. Someone started faxing pi. Well, I say started, right? But at the bottom it says page 1 of 1,950. But then at the end it's just like, lol, and then it stops after 4. So there you are. Someone sent a selfie with the fax machine, which looks surprisingly like our tech crew. Was that our tech crew? You jerks, honestly. This one literally just says fax 1 of 1. It's not wrong.
Shall I?
Steve, yeah.
It looks like Theresa May is in. She sent us her Brexit plan. There you go. just to date this DVD, don't forget to vote. This is good. Appropriateness of public urination as a function of age. Obviously, it's quite high at toddler, quite high at, when you're old, so it goes like that. But what's really nice is there's a dip when you're at uni. There's a little, it goes back up. That's quite nice. A pie chart of do not, and try. And you'll notice there is no try.
Nice.
Someone's drawn a pie chart of a football manager's view on the commitment of the team. There you go. So that's good. I like this one just because they've brought their own graph paper. Well done.
Yes!
Nice. You're our people.
All right, my final one is my favorite one. Portion of graph crudely removed with my teeth.
Final facts. Oh, they're still coming! They're still
Oh,
coming!
we're not. They're coming in. Someone was polite enough to put a cover sheet. There you are. Basic fax etiquette, people. But then the next one is a full-page selfie. Who is this? Who is this? Do you have any idea how expensive thermal ink is? What was that?
I left the cover sheet for you.
You did do the cover. Yeah, that doesn't. Cover sheets don't buy ink. From us watching to you people on stage. Message, cracking show. So, should we do fax roulette?
Oh,
Because
let's do it.
I have had a chance to check. This is so good. So, someone has spent a very long time finally getting their fax to be sent. They realized, I haven't got a message. And so they've just written, I hate faxes, you suck. I almost missed the whole break fanning around. And then an angry selfie.
They were your graphs and your faxes. Thank you so much. Give yourselves a round of applause. And we shall continue the show with another experiment, ladies and gentlemen. Keep that applause going for Mr. Steve Moore.
So we've already seen a bar chart made of fire. We've already seen a parabola made of fire. I'm going to take it to the next level now with a plot made of couscous. For this, you need a giant metal square, like this one here. I don't know what you use your giant metal square for. I use it for science. And so this is going to be my graph paper, and I'm going to plot some couscous. So here we go. It's a scatter plot. Shut up. It's a random distribution of couscous, but if I take my bow and I play this plate like an instrument, it will become decidedly unrandom. Here we go. Oh, yeah. Thanks very much. So that's called a Chladni figure, and there are theoretically infinitely many Chladni figures. I've learned how to make 3 of them. I will show you the other 2 later on. They were discovered by someone called Ernst Chladni, and he didn't use couscous, he used sand. But basically...
That's just because he didn't have a local Waitrose, that's all.
Actually, pro tip, if you're going to do this, uncooked couscous, I found. So he discovered these things, but he didn't discover why the couscous goes where it goes. That turned out to be a really hard problem in mathematics, a problem of wave dynamics. And the problem stood for a very long time. Most of the work was done in solving this problem by another mathematician called Sophie Germain. Sophie Germain was doing mathematics back when you needed a penis. So she did most of her work under a pseudonym, Monsieur Leblanc. Monsieur Leblanc did very well at school. Basically, Monsieur Leblanc dropped out. She kind of snuck in and took his homework and was doing it on the sly. And everyone's like, "Why? How he got good?" It's actually Sophie Germain. So she personally didn't get any recognition while she was alive. Things did get better, but annoyingly, only after she died, things improved. Another mathematician, Gauss, declared, we must give this woman a posthumous degree. So he's cool, we like him. Yeah. I really wanted to show you like a graphical representation of the mathematics that Sophie Germain did, what she worked out. And to begin with, all I could find was an equation. And so this is an equation of how the plate moves. This is what she had to work out, how the plate moves. And it's not that easy to see from an equation. But if you put it into Excel, you start to see something. Yeah. And then you do a 3D plot. Ooh, like that. Nice. And then what you do is you fix the colors so it looks nice. And then you take about 1,000 screenshots, just changing slightly, and then you get an animated GIF. Yay! And so this shows you what's happening. When the plate is vibrating, the parts of the plate that are moving, they jiggle the couscous around. And so the couscous moves until it reaches the parts of the plate that aren't moving, and it settles there. So where the couscous is, those are the parts of the plate that aren't moving. It's essentially a standing wave, like you saw with the flame tube, but in 2 dimensions, a 2-dimensional standing wave. Absolutely amazing. I want to show you the other 2 that I managed to come up with. So what I have to do first is just reapply my couscous randomization function.
The couscous is actually the seed in his randomization function. Look, well, that's technically the funniest joke in the show.
Okay, no one laughed because couscous is actually a grain, not a seed. Yeah.
That's not why people didn't laugh, is it? Come on. Okay, so I can force a different pattern by pinching the edge and creating a different set of nodes. Okay, here we go. Yeah, beautiful, huh? All right. Right, let's see. So here we go. Matt hasn't got a joke for the second time I do it, so it's just awkward silence while I... Here we go. Final one. I learnt this just the other day. Let's see if we can do this.
Okay, that is cool. That's very cool.
Chladni figures, ladies and gentlemen! Thank you very much.
Okay, that is very cool. But yet not the biggest round of applause lines of white powder have ever gotten. Blue Peter presenters, eh? No, don't. Don't applaud, it's not going in the edit. So, right now, I have been into mathematics for a very long time. I actually first got into maths when I was at school. because I thought it'd make the bullying seem less arbitrary. And I've had a great career of doing and teaching mathematics ever since. But I do have hobbies outside that, and my main hobby is recreational mathematics. And now this is something a lot of people do, and often people don't realize, because a Sudoku is a perfectly fun way to pass the time, and that is a type of recreational mathematics. But for me, a Sudoku is barely scraping the surface of the fun you can have putting numbers into squares, right? I actually think the best use for one of these is not solving it. The best thing you can do with one, and you have to try this, is the next time you're on public transport, right, get a newspaper, flick through, find the Sudoku, get a pen, and then just start filling in random numbers. But look like you care. It really pisses everyone else off. Oh, it's so good. If you get someone hooked over your shoulder, put in a whole row of sevens. Think for a while and then put a 12 in one square. It's so good, right? But the reason I don't like these is because you're not using the numbers as numbers, right? You're using them as digits. They're just glorified symbols. Exactly the same puzzle would work if instead of numbers you used letters, right? That would work. Actually, you could solve the same thing if you have 9 different punctuation marks. You could solve it with 9 different wingdings. You could even solve it with 9 different facial expressions of Nicolas Cage. For that puzzle, the Sudoku Cage, right? So if you're going to... I know you're applauding him and not me, right? So if you're going to solve, if you're going to put numbers in a grid for fun, at least use numbers that mean something. And so I'm now going to show you a vastly superior number puzzle that you can do instead of Sudoku. Now, to do this, I need the help from a maths teacher. So to find our maths teachers, we're going to do a survey. Maths teachers love surveys. All right, so if you're a maths teacher, give me a cheer. Okay, that is the sound of the maths teacher work-life balance, isn't it, sir? Are you actually a maths teacher? You were. Okay, fair enough. We'll go with... There are probably more ex-maths teachers than actual maths teachers. If you want to get back into the game, I can recommend a school that recently faxed me about an opening. So anyway, sir, would you mind helping me out? What's your name? James. Okay, James, you're going to give me a number, and I'm going to make you a mathematical gift based on that number, which you may then have. And you can either give me your age or a random number between 21 and 65. Whatever you prefer to share. What would you like? 26. Good choice. So, 26. 26. There's more. How disappointing would that be, right? Now, here we go, because I can put a 3 there, I can put a 5 here, and what I'm doing is I'm making something called a magic square, which has been part of recreational mathematics for thousands of years. 3,000 years ago in ancient China, this magic square existed, and if you add up every single row, column, and diagonal in that grid, you get a total of 15. Hundreds of years later, Benjamin Franklin came up with this one here, and that's an 8x8 grid where every single row, column, and diagonal adds up to 260. Whereas what I have done, I think, believe me, someone will check, is a grid where every single row, every single column adds up to 26. I'm just checking, yep. Or the columns add up to 26, yes. If I got it right, both the diagonals add to 26, all 4 numbers in the corners add up to 26, any 4 inner corner adds up to... You know, I just keep listing facts until you start applauding. Opposite pairs of you guys. How unprompted of you all. You know, I probably shouldn't have shown you an 8x8 while doing a mere 4x4. Right, James. So seeing how apparently this is insufficiently impressive, we're going to try again. I'm going to do a much larger grid. I'm going to try... Could you pass this back to James for me? James, I'm going to do a much larger grid. I'm going to do a 10 by 10 grid, which normally gets an ooh, but, you know. No, too late. So for this, I need a much bigger total, anything between 100 and 1,000. Any 3-digit number, what would you like?
429.
You really put some thought into that. Okay, so 429. I'm now going to do a 10 by 10. I would, but the thing that's more important in the room than you is Ben with the camera over there. But I'm glad you deemed that... You're pointing at the other camera going, well, this guy's not getting as many shots as Ben is. Now, just because I know the choreographing of this, you're in for a treat in a moment, because when I do this, I'll turn it around and solely show you guys. Don't worry, it's going to be amazing. And now, a brief pause for an edit break, and then we resume like nothing ever happened. Well, I'll go from writing the number. Shh, you weren't talking then. 29, and so... It doesn't work if you laugh at the number. So anyway, right, so I'm going to do a 10 by 10 grid where every single row, every single column is going up to 429. This will involve 10 to 15 minutes of you all sitting in silence. Or instead, while I'm doing this, we have a highly distracting musical extravaganza planned. We're going to welcome to the stage our guest star who has recently completed a world tour. Put your hands together for the Sun!
Ooh. Sorry, coronal mass ejection. Hi, I'm the Sun. Okay, not that many of you recognize me. It's fine, I don't make a lot of appearances in this country. I'm doing this as a promotional spot, unpaid, because it's come to my attention that people here on Earth are not looking at me, your local celebrity, enough. It's true. You're all spending all your time tweeting little boxes of electronics bouncing around on distant comets. You're all spending your time looking at other parts of the galaxy being pointed at by floppy-haired Mancunian professors. You know who I mean. You are not looking at your local helio-celebrity as much as I would expect. And that, ladies and gentlemen, to be perfectly honest, has made me annoyed. This sun has got its huff on. I used to be someone, now I'm just another sun, one of 100,000 billion. You treat me insignificantly, you name a tabloid after me. Synonymous with paparazzi, just a backdrop for Brian Cox on TV. Since Edwin Hubble, it's never been the same. Those pictures of other stars pushed me out of the frame. You never even gave me a proper name, something like Alpha Centauri or Epsilon Tauri or Delta Libre. I'll even take 8 short, so 948. Or Kevin. You've achieved nuclear fusion. Oh, well done, Earth. Made a little helium from a little hydrogen. That's very cute. But every second I do that to 600 million tons. If I was Marilyn Monroe, you'd be the one I can't remember the name of from One Direction, which is all of One Direction. And you should have stopped at Copernicus, and then I'd still be the center of your universe. You say I'm just an average ball of gas. Ah, I say you're talking out of Uranus. 1.4 million kilometers. That's my diameter. Tell me seriously, with those parameters, have you ever tried to put a hat on there? Hip, 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 hooray.
Well, I'll be a red giant someday, and your world will go up in flames. But in the meantime, please join my Facebook fan page. Seriously, it's only got 9 likes. Well, it's gone down to 8 now since Pluto defriended me. I will shine.
Thank you very much.
Thank you very much. Thank you very much. Thank you very much. Thank you. Thank you very much. Thank you. Has he finished yet? Thank you very much.
Ladies and gentlemen, a 10 by 10 magic square! Yeah! All right, so... whew, every single row, every single column adds up to 429. I didn't have time to do the diagonals, very sorry. If that's an issue for you, do your own. And some numbers are in there more than once, but it all kind of works. What I've actually done, if you're curious, is I have memorized other magic squares, and then you do the mental arithmetic just to adjust numbers up and down to hit a new target. I will, James, you can have a copy of this after the show. You can double check it. Some of you are now. If you want to find out more about how it actually works, James is a maths teacher. He'll explain it to you. So a final round of applause for my 10 by 10 magic square. Thank you very much.
So, I became a dad recently. Yeah, thanks. Well, I mean, it was easy, but for me, anyway. I stop trying to check Matt's maths. I'm going to turn this around. Sorry, I'm not going to be upstaged by a square and that thing that he drew. So I want to talk about childbirth. You know, childbirth is a wonderful opportunity for data collection. Honestly, it is, because when you go into labor, you get asked this question all the time. How long are your contractions? Everyone wants to know, the midwives and the doctors, because the closer you are to giving birth, the longer your contractions become. So this is an important data collection task that you have. And in the old days, you might use pen and paper to keep track of it, and, you know, a clock on the wall or something. But these days, the modern pregnant nerd can use an app. So I downloaded an app for my Android phone. Apps are available for iPhone as well. If you've got a Windows phone, you can use it to scrape the numbers into a rock. I don't know what you people do. And the way the app works is there's just a big button on the screen, and when the contraction starts, you press the button, and when the contraction stops, you press the button again, and it just takes care of everything. It's amazing. And that's quite a nice job for Dad, because Mum's quite busy, and she hasn't got time for your stupid fucking app. So that was me. Is it happening now, darling? Because if you don't tell me, it doesn't work. So I'm helping. So I could see that Leanne's contractions were getting longer and longer, and so I thought, okay, we better call the hospital. I phoned them up and I said, my wife's contractions are 58 seconds long. That's the average over the last half an hour, by the way. I can also give you the average over the last hour. With this app, I can give you the average over any time period. Oh, you want me to come in? Okay, great. I'll bring my wife. So we drive to the hospital, we get there, and we've got this in our little room, we've got a pool there, because we're going to have a water birth, that's the plan. Which is amazing, by the way, except the midwives hadn't filled the pool with water yet, because they didn't think she was close to giving birth, even though her contractions were really long. And that's because there's another data point that they use, which is how predictable are the contractions? Like, are they all the same length, or are they all different lengths? And they felt that Leanne's contractions weren't regular enough. The problem is, Leanne wanted to get in the pool. Like, right now. So it was my job to persuade the midwives to fill it. Unfortunately, the app that I'd downloaded has a feature where you can extract the data and load it into Excel. And fortunately, I'd brought my laptop with me, so I was able to knock up a quick spreadsheet and a graph to show the midwives so that they could see what was going on. And I can reproduce that for you now. So we've got time of day along the bottom, length of contractions up the side in minutes and seconds, and this is the data that came out of the app. And so what's in? Oh, by the way, that's where I had to go move the car, so we'll go with that. That can go. But what you can see is that they're not very predictable. They're quite spread out. But as time goes on, it gets more predictable. It's more bunched up there. And there's a wonderful thing you can do with Excel, which is you can track how that changes as a function of time. It's the standard deviation, basically. So I was able to create a sort of envelope of possible contraction lengths and then project that into the future. So I was able to say to the midwives that, as you can see, there is a point in the future at which my wife's contractions become perfectly regular. And that's at 2055. And it's my working hypothesis that that is the moment my child will be born. Silence. So I said, look, I'll show you my working out. And at that point, they filled the pool. So that's great. Ladies and gentlemen, I can tell you that my daughter was born at 2054. No, it's all right. No, it's all right, because error bars, yes. Totally nailed it.
Okay, yeah, but it is an unusual name for a first child.
We like it. Little errors, we call her. Not really. She's called Lyra. There she is. She already knows the best angle for a selfie. She's worked that out, so that's good. I'll show you one more picture. This is when we discovered she's too young for Doctor Who. So there is an age limit, just so you know. Ladies and gentlemen, I present to you the most statistically significant baby ever, Lyra. Thank you very much.
Now, I'm amazed we have come this far through the show without dealing with one major source of frustration, and that is that from this stage we keep calling all of these things graphs, when as a mathematician I would never call any of these graphs. In mathematics, a graph is more like a network. That's what I would call a graph. These things, I give them their individual correct name. These are charts, plots, and diagrams. I see the frustration is so acute, it has rendered you all speechless. Yes, the show should be called Just for Charts, Plots, Diagrams. Please use the correct hashtag from here in. And so, in the spirit of our actual show, Just for Charts, Plots, Diagrams, I'm now going to show you my all-time top 5 greatest plots ever. So, coming in at number 5, I have got a top 40, but apparently the show is finite in length. Coming in at number 5 is the plot of the cosmic microwave background radiation. Coming in at number 4 is the plot of the density of the prime numbers. Coming in at number 3 is the plot of Die Hard with a Vengeance. Specifically the scene where they have to solve a maths puzzle. Coming in at number 2 is the plot Too Dangerous for the Albany Theatre. And finally, the all-time number 1 greatest plot ever is the plot that plots everything. And it uses this formula here, but that formula is actually just glorified coloring in by numbers. It's not as complicated as it looks. And I can demonstrate how that works with a bit more of a straightforward example. This here, my magic square from earlier, is actually a plot, because I could add a horizontal axis there, I could add a vertical axis here, and what we have is a 2D array of values. We could now color in this plot based on the values in it. And actually, I'm going to give that to James to do for me. James, you don't have to do any actual coloring in. I'm going to pass this. Can you pass that back to him? And I'm going to give you some post-it notes. So our threshold value, can you pass them back to him as well? Right, our threshold. People are looking very excited about free stationery all of a sudden. Right, threshold value is 34. So any values 34 or below, cover the square up with a Post-it note. You've already employed a helper. Good. See, you're still a teacher, James. All right, and so I want you to cover them all up. When you're done, don't panic, just relax. I'll come back to you in a bit. You've got a little while, don't worry. Okay, right, so while James is doing that, I'm going to do the same color by numbers up on the screen, but instead of using a threshold value, I'm going to use the formula we saw a moment ago. And what you do here is you put your x, y coordinates in where the x's and y's are. You then crunch it through that formula. You got some mods, some powers, some floor functions. Eventually a value comes out the other side. If that value is greater than a half, you color in that pair of x, y coordinates. If it's not greater than a half, you don't. And if you color in all the points on your XY plot which match this formula, you end up with this plot here. Okay, some of you are... No, it's everyone or no one, okay, right? So if you're wondering why some people started to applaud, let me break it down for you. At the top, right, that is the formula for that plot. That is the plot of that formula. If you're still wondering what's going on, look what happens if I line up the formula with, it plots itself, right? It's a self-referential function, right? And when I first saw this, I was like, no way. There is no way that does that. And so I plotted it myself. And I can guarantee you it's true, it works, it actually does that, and it only cheats slightly. And that tiny little cheat is, I haven't told you what the K value is on the vertical axis. And that K value actually equals that. We're a long way up the vertical axis right now, okay, right? So actually, I've ignored a huge amount of the plot below that. There's loads underneath it, there's loads above it. In this one tiny strip, it happens to plot itself. And the reason it plots itself is because it plots everything. Every 17 by 106 image is in there somewhere, just with different K values. And so I went through and found them. So I went, well, if every single one's in there, I should be able to find the same function, but with smiley faces instead of the mod function. That's nice. I should be able to find the same function under the effect of gravity. There we are. I should be able to find it with Pac-Man eating it, right? It should be in there with penis crudely scrawled underneath, right? Every single one is in there. And if you're wondering how, for those of you who want to know how it works, a lot of you don't, tough, we're doing it, right? So if you take the image you want to find and you turn it into a binary number going left to right when it's on its side, and then you multiply that number by 17, that gives you the K value, which I've put in base 10 here. It's actually a bitmap function that plots itself. It was a guy called Jeff Tupper in Canada. Not a lot to do in Canada, who came up with this, right? And it's absolutely incredible, right? And some people get a bit overexcited about it because everything that possibly could be is in there. So people are like, well, hang on, E equals... Oh, it's in my book as well. How did that get there? So things make in the fourth dimension if you want to learn more, although the K value I put in the book is deliberately incorrect. It's the world's most tedious Easter egg. And so, right, so I found E equals MC squared. That's in there. That's kind of fun. People are like, Einstein could have just looked it up. And I'm like, no, because every single incorrect one is in there. E equals MC cubed, that's meaningless. All our names are in there. James, I took the liberty of looking up your name. There you are. That's your K value. I mean, you've got to share it with everyone else called James, but how many can there be? Right? And so, or the Jameses. The James are an emotional species. So absolutely everything is in there, and it's actually, the way it works, it's a bitmap function, all right? And so it's a bitmap function that plots itself based on the K value. It's very, very clever. A guy called Jeff Tupper came up with it. And when I read what Tupper had done, I was like, this is really clever. I was like, oh, what could I possibly do, right, that compares to this? I thought, you know what? I'm going to make my own version of Tupper's self-referential formula. And so when I was learning to make a 10 by 10 magic square for any number given to me by an audience member, I learned to do it in such a way. If you pass that down for me, James. Okay, thank you very much. So I made a 10 by 10 magic square such that all the lowest values make the same smiley face that appears at that. Thank you. Thank you. Very proud. That's yours to have, James. Pass it back to him. Okay, and so, all right, now at this point, I thought I was done. But then I started telling people about this, and the people were like, well, what's the point? What's the practical application? I'm like, oh, why, it doesn't have to have a practical application. But I was like, you know what, I'm taking that as a challenge. I'm gonna find a practical use for this in my life. And then, when Steve had a child, I was like, well, hang on, right? I could make, for Steve's child, the tupper plot with the k-value for the contraction data of its own birth. And some of you may be thinking it's not appropriate for me to have access to Steve's wife's contraction data. And frankly, he shouldn't have put it on GitHub. All right? And so once I had this, I was like, you know what? I'm going to get a cross-stitch designed, right? Which, now, normally I wouldn't give a gift to a newborn because I don't see the point of giving a gift to someone too young to make permanent memories. But on this occasion, I made an exception, and there it is. I got it cross-stitched, I gave it to her, and that, ladies and gentlemen, is the most statistically significant plot ever, the plot that plots everything. Thank you very much.
Well, we are almost at the end of Just for Graphs. We have one more thing before we leave you to head off into the outside world.
If you've enjoyed this DVD, we are doing live shows all over the country, all the time, sometimes all over the world. So go to festivalspoken.com to find out where.
You can also, on the same website, buy a copy of our previous DVD, Full Frontal Nerdity, which is available with English subtitles for accessibility and binary subtitles for inaccessibility. And there's also, we've all got books and stuff and Steve's ridiculous T-shirt. So do check out the website.
So we have come to the end of the show, and it's difficult to tell what graphs are really for, because I think they can be all things. They can be, for me, emotional. For Steve, they can be experimental. And for Matt, they can be mostly tedious. But I think we can all agree that graphs are magnificent. And to that end, I have written an emotional solo ballad to the power and the majesty of the humble graph.
Yeah, it is a solo, but I'll be providing backing on PowerPoint slides.
Which is unnecessary because I'm going to provide backing on actual physical slides. All right, yeah, look at this. Some of the young people have no idea what's going on right now. Like, why is his remote got string attached? That's so good. Right, so if I power this thing, let me fire this thing. Oh, yes. Now, if you're not familiar with these, this is what you use to adjust the vertical hold. There we go. Right, so now the way these things, let me see if I can line this up. The way they work is you get an actual slide, right? So I've got, like, look at that. That's a real physical slide. You put the slide into the projector, right? And then when you hit this button here, pow, it... Look, shut up. It's really high resolution. Okay, so you're going to do the song, I'm going to do the backing maths. Let's do it.
You can show all the world's people in a bar chart.
And you can plot every mountain on Earth.
It's not just a picture, it's an actual plot of a mountain.
And if you wanted to chart every star in the sky, well, you could try.
This is actual Hubble Space Telescope data. Available for the first time in slide form.
But you would probably run out of slideshow before you were done. But that's what Matt thinks is fun.
Do you have any idea how expensive it is to get slides printed these days? Very expensive. Oh, what? They don't fit that way. Hang on.
But you can't graph, no, you can't graph. You can't graph love.
You can't graph love.
You can't graph love. That is the name of the song. Love is too big. Love is too ineffable. How can you put axes on an emotion?
Oh, challenge very much accepted.
Steve, do you want to do a verse?
Yeah, all right, I go.
You can't graph an abstract concept like happiness.
You totally can.
But you can't plot something like justice on earth.
You got this one too. Oh no, I put it in upside down.
And
Easily
you
done.
could never plot out the meaning of life. Well, you could try.
This one's easy.
Oh, the meaning of life is the birth
Data
of your-
collection.
Oh.
And the birth of my child.
All right, that's a number of things that it's possible to plot. But there's one thing that's not, 'cause you can't chart what's happening inside my heart. Oh, very clever.
Okay, that's a diagram, not a chart.
Oh, whatever.
Here's how well Steve understands diagrams.
But you can't chart love. You ready, Matt?
It's really hard to tell in advance.
How can love be reduced to a graph or an equation?
Like so? Oh,
Ooh, 7 out of 10. But how can a formula ever show how I
God.
feel?
formula for oxytocin, people.
Yeah.
Being produced in your brains right now.
Yeah.
I like the fact that your slides are so tiny you can't fit the whole molecule on. It's all right, guys. I've got you. There it is. You know, this is what you really want to see, though.
Check out the frame rate on that. Woo! But how can an equation ever show true love? I don't even know what that means.
I had no idea what it stood for either. I had to look it up. Apparently, it stands for British Aerospace Electronic System. And for young people, that's like super romantic.
I actually think you're doing quite well, Matt. I mean, given how much space you have available to you, which is this much, by the way. Whereas I have this much.
Mine update quicker. Ready? What?
And how can the power of graphs be equal to the power of love?
Okay, that's literally the power of love. Sorry, it's not on fire. Or is it? Yeah.
But you can't graph. I looked this one up. You definitely can't graph. I'm serious about this. You can't graph an everywhere continuous function which is continuously differentiable but nowhere monotonic.
No, hang on, no, she's right. You genuinely can't. You can't plot that, right? Because to be
Yeah.
nowhere monotonic. No, Steve,
can't
no,
do
you
it.
can't.
No, I've got an idea.
You know what to do it.
No,
To be nowhere
no,
monotonic.
leave
There can be
it.
no
Wait,
interval
leave
of any
it.
size.
You
You just
You've got to graph. Woo! You've got to graph. Everyone! You've got to graph. That was everyone to the nearest no one. You've got to graph. Come on! It takes 17 muscles to frown, but only 3 to graph. You've got to graph. Woo! You've got to graph. Poop, 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 poop. You've got to graph.
All right, guess what we're gonna do? Christ! Oh, and I got this. Oh, holy balls. Okay, here we go. Oh my goodness. Okay, ready?
go.
Ready?
Yeah.